Alright, sections 8.6 and 8.7 are really going to be a review. So we're going to use all of our conics and the fact that we know how to graph a line to solve conics, systems of conics by graphing. In section 8.6 they just have you complete the square and then name the conic, but you've been doing that section on every quiz the whole chapter, so that should be pretty easy. So just some things to remember. Remember that graphing a line is just y equals mx plus b, so there's no squared terms. In parabolas, there's one squared term, and it's either a y equals or an x equals, and that gives us basically if it's up or down, left or right. Circles, we know there's no coefficients, and it's equal to a number out here, and that's always r squared to get us our radius. Plus sign for circles. Ellipses also have a plus sign, but they have denominators that are different numbers to make it an ellipse. Remember, a is always the biggest number in ellipse, so that's why we use this equation. A hyperbola has the minus sign, and c is always the bigger number, so that equation changes. The a in a hyperbola is always the first number. So in section 6, all they have you do is complete the square and decide what kind of conic it is. You should be able to have an idea before you even complete the square of what kind of conic it is. So in example number 1, you should notice there's only one squared letter, so I should know that that's a parabola. Now if I know that that's a parabola, then I know that I want to get the letter that's not squared by itself. So I would say let's move the 3y to the other side. So we have x squared plus 6x, and we know we're going to have to complete the square. Plus 6 is equal to positive 3y because I've moved it. So if we complete the square with the 9, then I can add 9 to this side, so I'm going to subtract 9 from this side, or you could put plus 9 over here. It doesn't matter which method you use. This would be x plus 3 squared minus 3 equals 3y. Now I've got to divide the whole problem by 3. So my equation would be y equals 1/3 x plus 3 squared minus 1. And that's all you're doing in section 6. In number 2, we notice we have two letters that are squared. We notice there's a coefficient, but there's no middle terms. So I don't have to complete the square because there's no middles to complete it on. So all I need to do is get rid of this coefficient. Well, anytime you need to get rid of that coefficient, you know this side needs to equal 1. So divide everything in the problem by 16, and you get x squared over 1 plus y squared over 16 equals 1, and that would be an ellipse. We need to make sure we are spelling these correctly. In number 3, again, you have two letters that are squared, and neither of those squared things are negative. So it's either an ellipse or a circle. Not sure which. I notice I have a middle term, so I'm going to have to complete the square for the y, but there's no middle term for the x, so I shouldn't have to complete the square for the x. So we'll take the 25 out and get y squared minus 2y, leave some space, plus 4x squared equals 75. Complete the square with a 1, but that's really 1 times 25, so over here I'm going to add 25. So it's 25 factor to y minus 1 squared plus 4x squared equals 100. I have coefficients, so this needs to equal 1, so we'll divide everything in the problem by 100. We end up with y minus 1 squared over 4 plus x squared over 25 equals 1, and again that's an ellipse. So it's important you know what it is you're graphing for the next chapter, or the next section. And finally, example 4, you have both letters squared, and you notice that one of them is negative, so we know we probably have a hyperbola. We also should notice there's no middle term, so I shouldn't have to square anything, or complete the square on either letter. So I'm going to move the 9 to the other side, so x squared minus 6y squared equals negative 9. There's a coefficient, so this needs to equal 1. So I'm going to divide everything by negative 9. So that would give you x squared over negative 9 plus, now remember, 6 divided by 9, you can't do that. So you have to put that all on the bottom. That would be divisible by 3. So 2y squared over 3 equals 1. Well, things that you should notice here. The negative is now with the x, so we need to reorganize this, and we still have to make this fraction be in the denominator. So our final answer would be do the y squared first, because that's the positive one. So y squared over, multiply by 2/3 is divide by 3/2. Or you could put 1.5 minus x squared over 9 equals 1, and that's a hyperbola. So again, completing the square is important for section 6. In section 7, they're going to have you solve the system by graphing. Now the good part here is when we say graphing, we don't have to have all of those details about a parabola or a hyperbola or an ellipse that we needed when we were actually naming all the parts. So you might be able to just use charts to make your graphs. What you want to be able to do is recognize what is the graph. So in number 1, this one's a parabola, and this is a line. So we're just graphing a parabola and a line and going to find out where they cross. So if you do the parabola first, we would say, well, what's HK? Well, there's nothing with H, and this is K, so the vertex of our parabola is 0, -5. Or this parabola moves down 5. So 1, 2, 3, 4, 5. Now I don't need the foci, I don't need the lattice rectum, I don't need any of that stuff. If you remember correctly, a real quick way to graph a parabola is to just put a couple points in. So you're at 0, so let's plug in 1. 1 squared is 1, minus 5 is -4. So 1, -4, and then use the axis of symmetry to get the other point. Now you want to have pretty good graphs, so you need a few points. So we'll plug in 2, and that would give us -1. So 2, -1, again, use the axis of symmetry to get this part of the graph. So here is our parabola. So they're a little faster to graph because you don't have to name all the parts. Now you're graphing a line. Well, M is 1 and B is -3. So you start down at -3 and you count up 1 over 1 to get your line. And already you can see where they cross because I got an orange dot on top of a blue dot, and that's going to be our answers. So remember, we're trying to figure out when these two are equal to each other, when they have the same solutions. So it's going to be at this point and at this point, which happen to be really nice ones. That's -1, -4. And this one is 2, -1. So those are your solutions. So just like when we graphed two lines as a system where they crossed was the answer, now it's just different pictures. Alright, so number 2. What is this a picture of? We don't have any coefficients, so 25 out there is okay. So I would say, well, that's a circle. So let's graph the circle. What's the center of the circle? Well, it's 0, 5. 1, 2, 3, 4, 5. And our radius is also 5, the square root of 25. So we go up 5, down 5, to the right 5, to the left 5. And you need to be as good as you can at drawing these circles, because remember, we're trying to see where they cross each other. So it could get difficult if you're not a good drawer. Alright, second part here is an x squared. One of the letters is squared. That's a parabola. Okay, what's the vertex of the parabola? Well, it doesn't move up or down or left or right, so it must be 0, 0. Okay, well if that's the vertex, you know one of your answers has to be 0, 0. We also know that this parabola goes down because it's negative. So we make a little chart, plug a number in. We're going to plug 1 in. Remember, square it first, then take negative. Use your axis of symmetry. Plug 2 in. Square it first, you get 4, then negative. And use your axis of symmetry. So you get this parabola. And where do these two cross? Only at this point. So the answer is 0, 0. Alright, then they switch it over and they make them inequalities. So what we need to remember with inequalities is we need to shade and we need to do dotted or solid lines. So number 1, we have a parabola. The vertex is 2, 0. So 2, 0. Its y equals, so we know it's going up. So make a little chart. That's always going to be your fastest way to do this. So since that's 2, I'm going to plug in 1 and 0. If I plug 1 in, I get negative 1 squared. It's 1. Use your axis of symmetry. If you put 0 in, you get negative 2 squared, which is 4. 2, 3, 4. Use your axis of symmetry. And there's your parabola. Now, it should be solid. Should check that before I started. That's supposed to be solid. Now, where would you shade? We're going to shade that inside. Okay? Now, I don't want to shade yet because I want to put my other picture on, so then you're going to look for where the shading overlaps. So just make yourself a note that you want to shade the orange one on the inside. Alright, this is going to be a circle. So I know that the center of this circle is negative 1, negative 1. And I know that the radius of the circle is 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And it should be solid. Again, I should probably check that. And where would you shade? If you want to be smaller than the circle, then you want to be inside the circle for your shading. So if you're inside the orange, all in here, and you're inside the blue, they would cross each other in this little section right here. So what I'm grading here is where you have it shaded properly. Alright, tomorrow we'll do these problems by algebra, because you can see these are only nice up here because I gave you really nice ones. But if I drew my parabola somewhere else, you wouldn't be able to tell me where it hit that circle. So we're going to have a better method than graphing. So tomorrow's will be nice graphing ones, and then the next day we'll do them by algebra. So the next video will be the finish of this notes page.